Hi everybody. Today we're going to talk about sketching and analyzing uh, graphs of reciprocal functions. Now I want you to remember that the basic reciprocal function is y equals 1 over x. And since x can't be 0, we know there's an asymptote, a vertical asymptote here at x equals 0, because we're not allowed to divide by 0. 1 divided by 0 is undefined. And as x gets really big, y gets smaller and smaller. So when x is 2, y is a half. When x is 1, y is 1. When x is 2, y is a half. When x is 3, it's a third. When x is 100, it's 1/100th. It's really teeny tiny. But when x is a fraction, like a half, 1 divided by 0.5 is actually 2. So the graph gets closer and closer this way. So the graph itself looks something like this. And if it's negative, the value is just negative over here. If x is negative, y is negative, so it looks like that. So the graph comes in two pieces, even though it's one function, and there are asymptotes at x equals 0, because x can't be 0, and y equals 0, because I can't do 1 divided by something and get 0 either. So that's the basic graph. And we're going to be transforming it using that center point where the asymptotes cross. So it's going to work just like all the other transformations, right? We've been looking at those before. Y equals a over or divided by x minus h plus k, where h comma k is the center. That's this point right here, and a is the vertical stretch. And we'll talk about that in terms of an example. So let's go back to this first problem. Because the denominator says x minus 6, I know that x can't be 6, because 6 minus 6 would be 0. We're not allowed to divide by 0. So 1, 2, 3, 4, 5, 6. There's an asymptote there at y equals 6. And since 4 divided by something can never be 0, this part can't be 0, but really close to it. But if we add 2 to something really close to 0, that means we're at 2. So there's a horizontal asymptote at y equals 2. And now we just have to fill in some pieces. So let's do the vertical stretch is 4. That means if I go over 1 from the asymptote, I got to go up 4 on one side and down 4 on the other. 1, 2, 3, 4. So that's 1 point. And if I go over 1, 2, 3, 4, that's the other point. So I've got to connect up those points. You see, this one just follows the asymptotes again. But it's not as close to the center point as the graph over here, because we've got that stretch of 4. So if I'm going to talk about this particular one in terms of the features, the domain is all real numbers except, I wrote that wrong. The vertical asymptote is x equals 6. Sorry about that. The domain is all real numbers except for 6. I can't plug in 6 for x because that would give me 0 in the denominator. So we just write x does not equal 6. And the range, since we never get to y equals 2, there's that asymptote there, we know y does not equal 2. To find the y-intercept, as usually, plug in 0 for x, so I get y equals 4 over 0 minus 6 plus 2, so it's 4 divided by negative 6 plus 2, which is going to be negative 2/3 plus 2, which is going to be about 1.33. We did the asymptotes already, x equals 6 and y equals 2. Let's talk about end behavior really quick. Remember, that's where the graph is going as x goes to infinity and negative infinity. So these two arrows going left and right, and notice they're leveling out at 2. So we say as x goes to infinity, y is going to 2, and as x goes to negative infinity, y is also going to 2. We'll talk about behavior near an asymptote in the next video. Thanks, everybody.